In recent times, there has been an explosion in GPT models, and popular ones such as ChatGPT and DALL-E 2 have been gaining a lot of attention. DALL-E 2, for example, is an image GPT model that can create realistic images and art from a given description. These models have shown incredible capabilities, but they also come with their own set of biases. Researchers have shown that such models are susceptible to bias, particularly towards women, where a cropped image of a face will be completed with a background from a home or domestic setting, while a man will be situated in a business or a professional setting. To add to this, the woman's clothing will be overly sexualized, such as wearing a bikini. To understand these biases, we need to look back at the origins of the training data. In 1966, Marvin Minsky was a young professor at MIT, making a name for himself in the emerging field of artificial intelligence. Deciding that the ability to interpret images was a core feature of intelligence, Minsky turned to an undergraduate student, Gerard Sussman, and asked him to spend the summer linking a camera to a computer and getting the computer to describe what it saw. Needless to say, the project of getting computers to see was much harder than anyone expected, and would take a lot longer than a single summer. After decades of fits and starts, it wasn't until the acceleration of technologies in the 1990s allowed the building of probabilistic modelling and learning techniques at scale. This led to the current moment, in which challenges such as object detection and facial recognition have largely been solved. This arc of inevitability recurs in many AI narratives, where it is assumed that ongoing technical improvements will resolve all problems and limitations. But can it? While the technical problem of recognising an object in an image is solved, this is very different from the problem of labelling the object that can actually teach machines not just to see, but to identify and label what they see. For this to happen, we need to teach machines what the objects they are seeing are. One of the most significant training sets in the history of AI so far is ImageNet. ImageNet is a dataset of extraordinary scope and ambition. Over several years of development, ImageNet grew enormous. The development team scraped a collection of many millions of images from the internet and briefly became the world's largest academic user of Amazon's Mechanical Turk, using an army of piecemeal workers to sort an average of 50 images per minute into thousands of categories. When it was finished, ImageNet consisted of over 14 million labelled images, organised into some more than 20,000 categories. ImageNet quickly became a critical asset for computer vision research. At the time, no one saw that ImageNet was actually flawed and would eventually suffer a significant downfall due to its bias. Images scraped from the web emphasise the human biases of the time, which is further exacerbated by the taxonomy used to label those images. The underlying structure of ImageNet is based upon the semantic structure of WordNet, a database of word classifications developed at Princeton University in the 1980s. The taxonomy is organised into nested hierarchies, going from general concepts to more specific ones. The classification system is broadly similar to those used in libraries in order to classify books into increasingly specific categories. WordNet itself is based upon the old Library of Congress classification system, famously under which this historically used to classify LGBTQ-themed books into the category abnormal sexual relations, including sexual crimes. The American Library Association's Task Force on Gay Liberation finally convinced the Library of Congress to change this classification in 1972 after a sustained campaign. Fields of information science and technology studies have long shown all taxonomies or classification systems are political. The biggest problem in WordNet, unsurprisingly, exists in the person category. ImageNet consists of 2,833 subcategories under the top-level category, person. ImageNet classifies people into a huge range of types, including race, nationality, profession, economic status, behaviour, character, and even morality. Delving into the depths of the person categories, the classifications of humans within it take a sharp and dark turn. There are categories for bad person, cool girl, drug addict, closet queen, convict, crazy, failure, flop. I'll stop there as alphabetically the next word is even less suitable for use in a video, but you get the point. In January 2019, images in the ImageNet's person category began disappearing. Suddenly 1.2 million photos were no longer accessible on Stanford University's servers. Gone were the pictures of cheerleaders, scuba divers, welders, altar boys, retirees and pilots. The picture of a man drinking beer characterised as an alcoholic disappeared, as did the pictures of a woman in a bikini dubbed as a slattern, and a young boy classified as a loser. Removing these datasets may seem like a victory, but it also removes an important forensic method to understand how AI systems work. Researchers are now unable to see how the assumptions, labels, and the classificatory approaches have been replicated in new systems, or trace the provenance of skews and biases exhibited in working systems. And it isn't only the taxonomy of images that face this problem. Many music classification systems still have a world music category that conveniently acts as a place for non-Western music. The same is true of museum collections. As they emerge online, these expose biases in the ways curators and collectors historically viewed the world. Again, both of these suffer the same problem as ImageNets. We are flattening the world and losing the nuance while also emphasizing certain worldviews of certain people. Addressing these challenges is complex, but we shouldn't simply delete datasets that have served as the historical source for AI systems that are now in widespread use. We need to preserve these datasets for future scrutiny so we can learn from our mistakes and not just hide them. We don't want black box AI, and researchers deleting data will only perpetuate this problem.